Okay, so what we just looked at is the interest rate tables or the factor tables. They can also be used for easier and quicker calculations. And this topic is important in transportation engineering because many projects take several years to construct and require maintenance over many, many years. And an accurate economic analysis helps decision makers select the best and most cost effective alternative when we're looking at doing projects. So here's a close-up view of a very typical cash flow diagram. If we just read we see that there's an investment made of $30,000 in a brand new machine. And its maintenance cost will be $2,000 per year. So we're indicating the $30,000 initial investment with one downward pointing arrow. And then we have a series of $2,000 maintenance costs occurring every year for 5 years. And we're told that this machine will generate some revenue, which is a good thing. It will generate $5,000 per year. So we've got upward pointing arrows representing that cash flow. And at the end of 5 years, the machine will need to be scrapped or it'll have a salvage value of $4,000. So that is represented by an upward pointing arrow as well. And what we can do is we can simplify this cash flow diagram to, as shown here, we've got one downward pointing arrow, which is how much we're paying for that asset today. And then the annual receipts and costs can be simplified. And we see a series of $3,000 annual receipts. And that's our revenue after we deduct the cost of maintenance and operations. And at the very end, we've basically added up the plus 4,000, the plus 5,000, and the minus 2,000. So we incorporated the salvage value in our cash flow diagram. Yeah, this was probably not the best investment because if you add up these investments, we've got 4 times 3, that's 12,000, and 7,000, so that's 19,000. And we paid $30,000 to get $19,000 worth of receipts. And this might have been something that we simply needed. We couldn't do without it. But from a business perspective, we'd always want to have more return on our investment than what we see here. In civil engineering, we sometimes get into public works situations where something is needed, like transit, and it's not going to make money. It will reduce congestion. It will enable people to get to work. It will do a lot of positive things, but it may not pay for itself. So a lot of the things that we as civil engineers end up designing or maintaining could be in that category where they're not really making money, but they're avoiding costs, keeping people safe, keeping people from getting killed. That could be a net positive event for society. Let's talk about the gradient. Gradients are a little bit more complicated, a little bit more interesting than the straight present worth, future worth, or uniform series. Another type of cash flow diagram shows a series of increasing costs, or could be increasing receipts. We want to think positive. And this is a uniform gradient. And the reason that it's called uniform is because the same dollar amount of change occurs every year. And notice that the cost is increasing by $250 per year. It's not a percentage. It's a set dollar amount of increase